Hello everyone, welcome back. In this video we'll be solving a simple beam example, that to cantilever problem using ANSYS software. So just right click and run as administrator, open. So this is the interface, so I can select ANSYS structural and we'll just give cantilever beam and just click run. And so save db you can give, go to preprocessing, structural, switch it on. Preprocessing, we need to select element type. So let us consider the same old problem which we had considered earlier. So length is 2 meter, the load is 50 kilonewton, and cross section dimensions are 0.45 by 0.3 by 0.45 meter, and one end is fixed. So element type we will use beam 188 element, 2 noded 188 element. So select beam 2 noded, click apply, and it will come. Okay, so the second one you just delete once it is sufficient, and just close it. And then real constant is not required for this. If you want, you can check it out here. So click OK. It won't be asking, it won't take real constants for this. And material properties, material models from this structural, non-linear, linear, elastic, and you can give 5000 root FCK, that is 2500 for M25 concrete, and 0.15 as the Poisson's ratio. Click add, close it. So material is ready. And cross section we need to define. So we not define cross section beam to beam and common, and you can select rectangle and give here width will be actually in this time ANSYS width will be taken as depth, and depth will be width, so 0.3 meter, and click OK. So the section will be added. Now you have to create the model. So modeling, you should go to modeling and go to create. So as I told you, so this works based on key points, line, area and volume, and this is the basis background for the elements and nodes. So create key points on working player or active CS also you can enter. So this is other method, 1 and 0 0 0 apply. So first node will be created, and for the second node you just give 2 meter, x value is 2 meter, and click apply. So automatically 2 nodes will be created. Next we create a line. So go to lines, straight line, click this node and the second node, and click OK. So we get the lines, and we have created the background, that's nothing but the skeleton. For creating nodes and elements, we need to do the meshing, as I said in the previous video. So go to meshing, and we need to map these element types, materials and sections to this line element, and later we can mesh the members. Okay, so go to mesh attributes and picked lines, click this line, click apply, and here you just map the element type, that is first material part type and the element type as well as section type, and click OK. So the elements and other things are mapped, and we need to, as I said, we need to divide this into finite number of elements so that the results will be accurate. So do manual sizing, and click picked line, select this and click apply, and we'll give as much as possible more number of elements so that the Benjamin diagram and the results will be accurate. Okay, and 100 elements I'm giving for 2 meter, and click OK. and then just do the meshings to create the nodes and elements. So go to mesh and pick the line and click OK. So meshing will be done and nodes and elements will be created. If you want to see the nodes and elements, click plot and multiplot, and you will be getting the nodes here. Okay, these are the nodes and elements, right? So next we have created the basic geometry. We need to apply the or give the support conditions, and we need to apply the load. So to do that, go to solution and first mention the analysis type, static analysis, click OK, and then define loads in that apply load, structural displacements on nodes. Okay, the last node you can consider, and click apply all degrees of freedom because it's a fixed support. And then we should give the apply the loads, go to nodes, and the last node you can select, click apply, and because it's a point load and acting downwards, so give minus 50 kilonewton. And actually did not mention the unit. So what you need to do is all the parameters whatever you are considering, they should be in meters and kilonewton. That's all, it is understood. And click OK so that you will see the applied loads. So we have created with the geometry, it is done. Next thing is to solve the problem, and to do that, go to solve current ls, click OK, and solution is done, right? And we need to go to view results. To do that, go to general post processing, and first thing is read the result first set, and then plot the results. So we should plot the results. As I said, we initially we can plot the deformed shape. So click deformed shape, undeformed and deformed, click OK. So this is how the beam it is deformed or bent like the cantilever beam, and it is fixed, and this is the maximum displacement is happened at the support at the free end. So next, if you want to plot the displacements along the length, you go to nodal solution, and nodal degrees of freedom, y component, click apply. So with deformed, without deformed, with undeformed model also you can see. So this is the undeformed and this is the deformed model, and values, variation of the deflection values you can see here along the length.